Okay, hello those interested in learning the Python programming language. Thank you for being with me in another educational video of this powerful programming language. I have prepared some exercises for you here. Let me explain a little about these. You will see a series of outputs here, but you do not see the corresponding code. I will explain how the inputs are considered here. I have prepared two files for you. One is the file on solved exercises for your further practice. I suggest that before you see the solution of these exercises by me in the rest of the video, you should it is better if you solve these exercises yourself and compare the output you received with the existing outputs here. You can use different methods to solve these exercises, but my suggestion is to use more optimal and practical solutions. Note that in solving the exercises, it is better to add a cell so that the outputs are not lost. Although you can use the continuation of the video to correct possible errors in your solutions. Let's solve the exercises one by one. In the first exercise, we define a variable for the number of letters in the S string. Let's see, what is the question? What is the problem actually? Given the following string, extract all the elements and produce the desired output by adding the appropriate element. Okay, here is a Udemy. Okay, let's consider, because this string has 5 parameters, we want to consider 5 variable actually for containing this s. Okay, okay, let me, okay, because we did not define this as, we got an error. Now because I forgot to add a cell here, so the desired output is lost here. The desired output actually was dummy, but in the rest of the questions and in the rest of the exercises, actually don't forget to add a cell in order to prevent this missing. Okay. Let's show these 5 variables. Okay, add a cell. Add some cells here. Okay. Let's show these 5 variables. Okay. So the S1 contains U, S2 D, S3 contains E, S4 contains M, and S5 contains Y. Hence, in order to reach the dummy word, we need to act like this. We need to actually add these variables, string format of variable actually together with these. Okay, you can see the dummy word here. Okay, we have said that there is no need for parentheses in the discussion of tuples. So here when we wanted to show these variables, although there were no parentheses, you can see that this is supposed to be a tuple. You can see in the output. Okay. The second one, for the list of numbers below, by removing the second element from the beginning and calculate the mean square of the remaining numbers. Okay, this is the desired output. Let's at first add some cells here, and then we want to write a function to perform operations inside the function. Let's define it. Def, keyword def, and the name, for example, could be average number. The acronym form, actually, the abbreviated form, which is average num. With the input argument num, for example, with the input for example, numbers. Okay. And then we want to say this is the first n, and the second one will be take away parameter, and the star expression mn, again take away variable, and last n. These are the numbers. Okay, and now we want to say that return, for example, this fn plus sum of these mn's and this ln. Okay, divided to len these mn's plus 2, which is for this last n and this first n. Okay, now let's call this average num with the input argument. Okay, actually we forgot to run this cell, and now okay, this is just an object. The average number is a function. We want to consider this num list as input arguments, and you can see that the output is similar to our desired one. Okay, we can delete the extra cells. Okay, the third one, produce the following outputs using a DQ. The DQ is inside collections, so at first we need to input it from collections, import this DQ. Okay. And we need to define a DE containing the similar DQ with the desired list 0, 2, 8, 16, 40. Okay, and then we want to show this DE. Okay, this is missed, the first one. You can see that the outputs are similar. Okay, here we want to add an 80 to this queue. It can be done in different ways, and here our goal was to use the methods. For example, we want to say DE that append this 80. And actually we can show this DE again, and you can see that the outputs are similar together. Now we want to add an 80 from the beginning, so we need another method, append left, the same input argument 80. Okay, don't forget to let's show this DE here again, and you can see that okay here because we run this DE.append 2 times, this problem was occurred. Okay, let's correct it. At first we want to for example DE.pop. Now DE. Okay, this is our D, our desired D. This DE we can do pop left. Okay, this is our DE. You can see that because we run the both cells which contains DE.append 80 and DE.append left 80 2 times, so the added 80s from the beginnings and the end of this queue was 2, and we remove them by this pop and pop left here. Okay, you can see that the outputs are similar in this state. Okay. Okay, here we need another pop left in order to pop these 80 from our queue. Let's show this DE, and you can see the output here. Okay, so in this way we have made and used the DQ. Let's go to the fourth. Generate outputs using the HipQ module. Here we have a list of dictionaries. These dictionaries are about companies, the name of companies, a number of workers of these companies, price of these companies, and the age of these companies. First, we run this dictionary. Now we want to generate these outputs using a HipQ. So first we need to import this HipQ. Import HipQ. Okay. Now here we need a pattern. Let's compare the values here with each other's. 8 208 is a bit okay. 8 200 and 101. There is no pattern. So this should not be the basis of this selection. So let's check the other key, which is price. 110.3, 100.8, 93.8. Okay, there is a pattern. The prices are decreasing when is compared to each other. But let's go to the list D, and see if the 110.3 is the largest price among the prices of these companies available in this list or not. Or we can check if the 93.8 is the smallest price for the companies available in the list D or not. Actually, here we have a 70.4, so the 93.8 is not the least price among the prices of companies available in the list D. So we need to check if there is a price larger than 110.3 or not. Let's see. Okay, there is no price more than 110.3. So this is logical if we think that the basis of this selection was the price key, and this was about to finding the three largest companies based on their prices. Okay, so let's delete HipQ.N largest. Remember how we use these? We need a key. We used lambda expressions, and we wrote these bases here. You can see that the output is similar. But remember that there were another way too, because the sorting is based on the price, and three companies with the highest prices have appeared in the output, so we used this code. We have also introduced item gather for these cases. Let's import it at first. Let's say from operator import item gather. Okay, now we want the same expression, but here the story is changed, and the key should be item gather apply on this price. Okay, you can see that again we got the same output. Okay, okay. So this output can be produced in this way. The next output is based on name, and the three companies whose names have the smallest index among the alphabet letters have been the selection criteria. So we need the same expression here. Instead of n largest, we have to use the n smallest, and actually it is better to use an item gather. For example, it was about name. Okay, this is name. we can see that the result is similar. Okay. In the next problem, grouping is done based on age. Let's have these. Expression copied here. It's about the age. You can see that the outputs are similar. Okay. And the next one actually is based on a number of workers. You can write the same here, and here we need to have number of workers. Okay. You can see that the outputs are similar again. The next exercise is a simple exercise using a default dict. Okay, at first we need to import it from collections, import default dict. Okay, now we want to have an object of this default dict based on a list. Then we need to append them one by one here. Here we have X and this list, S and this list, 5 and this list, and 5 and this list. Okay, so let's do it one by one. Actually smallest. Okay. Okay, and the last one. Now let's show this D, and you can see the output here. Let's go to the next one. produce the following outputs by performing calculations on the dictionary. Let's run the cell and let's add some cells here. Okay, AAP, actually this is the least one, the smallest one, the minimum one among the keys. So we can do min, apply this min built-in function on D, or we can apply it on its keys. No difference. And this time we need the max built-in function. Again, no difference if we apply it on the D itself or on its keys. This time we need to apply the min function on these values. Here we want to have the zip format of the values and the keys, because the values and keys places are replaced with each others, and among them we want to apply, we want the maximum ones. So we need to apply the max function at first, and then zip function, and then the values and the keys. Okay, and you can see that this is the desired output here. This time we need to apply the sorted function on the zip format of these the values and the keys. And you can see that this is the same output. At this time we want to apply this sorted built-in function on the zip format of these the keys and its values. Okay, the next one. In the following dictionaries, generate outputs using the method of finding commonalities. Okay, let's run this cell. Add a cell. Here we need the AND methods applying on D1 keys and D2 keys. Okay. Oh, I forgot to consider 1 and 2 here, so it applied this AND on the keys of D dictionary which was in the previous exercise. Okay, you can see that the outputs are similar here. This time we need to have the D2 dot keys minus D1 dot keys and you can see that the outputs are similar again. This time we want d1 dot items, not just keys or values, items, minus d2 dot items. Okay, you can see that the desired output is available here. Let's go to the next one, which is saying to us, create a class called car with the specified properties and generate the output. Okay, let's define a class car, and inside it we want to have the method init with the input arguments self, year, and a price. Here we want to say that self.year is the same year, and self.price is the same price. Okay, let's run the cell here. What is the problem? I cannot figure. Okay. If we run the cell here and do not say anything about the method representation, here if we run for example car 2100, here we will not see any visible result, so we need the representation method too. Let's back to the function and define the representation method too. Self return car okay, now use that format, self.year and self.price. We have talked about these a lot, and this time if we consider for example C as a list of car, for example 2100, let's accelerate our process by copy pasting, this time 2018 and 420, and this time 2020 and 1000. The next one is a 2019 and 220. This time we want 2014 and 170. Let's go to the next line. This time we want 1998 and 120. This time we want 2017 and for example 700. Okay, and just this. Now we want to show this C. You can see that the outputs are similar. Okay. Now we want to sort. At first we want to do this sorting based on years. Actually we need to import the attribute gather here and sort the C with based on the year. Okay, you can see the result. We can do this sorting based on the based on price. Actually we can get the minimum one based on the price again. Okay, let's go to the next one. Using the following data, perform the necessary groupings and generate the required outputs. Okay, let's run it. Let's add some cells here. We need grouping for generating this output. At first we should do this task based on color. Let's import from iter2. Import group by. Okay, from operator import actually item getter. Although we imported this item gather previously, but we want to have these import codes integrated here, so we import it again. Okay, now we need, for example, this car. This is the car. The first letter is a small c. Car. Dot sort. Key is item gather. CO, and we want to show this car. You can see that in this way the outputs are similar together. Okay, in order to achieving the next output, we should do like this. By these codes our data is sorted based on color, and now we need a for loop here for CO and car. In group by car, and the key is item gather. CO print this CO, and for C in car we want to print At first space, and this is enough, and then the C. And you can see that in this way the outputs are similar to what we wanted. Okay, add another cell. Okay, you can see that we have reached the desired output. That means we have to sort the data first and then group it. Another way to group is to use default dict. Before running the default dict code, we rerun the car list so that the effect of the changes we made on it will disappear. Let's go to the car list and rerun the cell in order to disappear, the wipe out the effects of these sorting and group by tasks. Okay, now we want to again say that from collections import default dict, and we want to say we want to actually define a variable named, for example, car by year is equal to default dict. Actually, this would be an object of this default dict, and we want to say that for R in car, we want to this from this car by year, from this row in car list, the column of year, we want to this be appended to our car by year, which was an object of this default dict here. And then we want to show this car by year here. You can see that the outputs are similar by this way. Okay, let's go to the next one. Filter the following data in such a way that if the value of each element is negative, it will multiply it by 2, and if it is positive, it will show it's a negative. Okay, this is our list. We want to say we want minus I if I is greater than 0, else we want I multiplying 2 for I in n. Actually, we forgot to run this cell, so we got an error, and this time you can see that the outputs are similar together. Okay, actually we can have the sum format of these numbers too by just copy pasting this expression inside the sum. Remember that we talked about that it is better to not to actually consider a list inside this sum because of the memory issues, actually memory optimization issues. Okay, let's go to the next one. Extract the desired subsets from the following dictionary. We use dictionary comprehension here. Excuse me. Excuse me. We want to say key value for key and value in D dot items if value is greater than 100. This would work for generating this result. Okay. Key and value for key and value in D dot items. Okay, oh, I forgot to consider parentheses here, and you can see that the outputs are similar in this way. For generating the next desired output, we need to define a set which is named names, for example, and we want to say this is A, D, and E, and we want the same expression with a slight difference if key in names. You can see that the outputs are similar in this way. Let's go to the next exercise here. Merge the following dictionaries and produce the desired outputs. Okay, here we need to import the chain map at first from collections, import chain map. Okay. Now let's define a CM as an object of this chain map, D1, D2, and D3, and we want to show these CM here. Okay. Now, for example, if we apply this, we want to see what is the CM of this B. You can see the result here. Or for example, we want to see the value of key C, and you can see the output here. And you can actually add a key which is named H, and consider the value 1000 for it, and then show this CM, and you can see that this is the output. Okay, here the exercises and topics related to data structures and algorithms, and from the next video we will enter advanced topics in working with fields, with actually strings. You could do many of these tasks that were reviewed in the last 8 videos with the same basic knowledge. But in these 8 videos I taught you how to code with better performance and more easily. The following videos contain valuable tips about working with strings, so I strongly suggest you stay tuned. Have a good time!